Alright, so I'm going to go through one more example, and after this one I'm actually going to do a bit of a proof example. This one here I wanted to go over because it doesn't just involve just basic trig, it actually involves the cosine and sine rules. So if you're unsure about those rules, there's a few videos on it that I've made, so go check those out. But I just wanted to go through this one, so let's go straight into it. So I want to find this x. And normally I'd be like, oh, it's a non-right angle triangle, I'm going to use my sine and cosine. However, I don't have enough information to help me. Right now I'm a bit of a pickle. So I know that I've got one side which is 4 centimeters, that's this one here. This angle is 30, and I've got one side of my triangle. So I've got two sides, I just need one more, and I don't have an angle. So we're trying to figure out what else we can do. I can find out this angle because it's on a flat horizontal, and anytime there's angles on a flat horizontal, you can always find the other one because straight lines equal 180 degrees. So because of that, I know that that's going to be 150 degrees, which kind of helps us at the moment because we're like, oh, is it sine or cosine? Straight up, I can say that is cosine because there are 3 sides and 1 angle, so that helps me a lot. So I'm just going to quickly write down my cosine rule, which is a squared equals b squared plus c squared, take 2bc cosine a. So I'm going to label my sides now, so I always make my unknown a. So it's my a, and then we've just got 2 other sides, b and c. Alright, so let's substitute it in. So x squared is equal to 4 squared plus 2 root 3, I'm going to put that in brackets, squared, take 2 root 3 times by 4, cosine 150 degrees. Okay, so remember, there's a few different things here. Actually, I'm just going to keep going and simplifying before I make my note. So 4 squared is 16 plus 2 root 3 squared. So remember, for this in particular, this is like 2 squared root 3 squared, which is equal to 4, and then this square and the square root cancel out, so it's basically times by 3, so that equals 12. Take away, so I've got a few things here again. I've got 2 times 2, which is 16, sorry, 2 times 2 is 4, 4 times 4 is 16, so I've got 16 root 3, and then I've got my cosine 150. Okay, you might be like, well, I don't have this in my exact values table, this is not helping me, what am I going to do? Remember that cosine 150 is also equal to negative cosine 130. So basically 180 take away 150 is 30, and the inverse is always just going to be the negative. The opposite is going to be a negative. Okay, so we know what cosine 30 is. Cosine 30 is root 3 on 2. Just make it negative. So x squared is equal to 16 plus 12. Take 16 root 3 multiplied by our negative root 3 on 2. There we go. Alright, so now what I'm going to do is I'm just going to simplify a few things. So I've got 16 plus 12, which is 28. I've got a negative multiplied by a negative, which makes a positive, so it's going to go plus. So 16 root 3 times by root 3 divided by 2. So there's a multiplier in there, so it's going to be 28 plus, so this root 3 and root 3 is going to simplify down to 3. So that's just going to be equal 16 times 3 divided by 2. So that simplifies down more, so 16 times 3 is 48, 48 divided by 2. So 28 plus 24 is equal to 52. We're so close. That's not our answer because remember, this is squared. So what we need to do now is that we're going to do x is equal to the square root of 52. And I'm going to break this down into a third, so I don't want to leave it like this. I want to change it into thirds. So I'm going to see if I can break it down into some squared numbers. So 4, 9, 16, 25. I'm going to see if I could break it down into those numbers and see if any of those numbers can form 52. So for this one in particular, I know 4 is a really good number to use. 4 is always, a lot of the time can be go into it. So 4 times by, I think it's 13. So from there, I can change this root 4 into a 2, so it becomes 2 root 13, and I'm going to put my units on there, so that is going to be in centimeters, and I'm going to highlight my answer. There we go. So that 2 root 13 is now this side there. All right, so I'm going to do one more question. This is a proof. So a lot of the times you'll have to be able to prove something, so they'll give you the answer, but you got to be like, how'd you get there? So you've got to use a bit more of your skills, because it's not always about using it but actually proving it. So let's have a go. So what I'm going to do is I'm going to break it up into a few different triangles. So I'm going to do I've got a few different sides that I need to use. So I'm going to need to know this side and this side. So it's going to be like a step by step. And because I'm solving for y, this one here, I'm actually going to start with this, because if I don't know this, I need to use this. If I don't know this, I need to work that out first, if that makes sense. So I'm going to start from the bottom up over here. So I'm going to label some of my other sides that I, haven't got. So let's say this is Z and this is W. All right. So I'm going to number my triangles. Okay, this is my 1, 2, and 3. All right, so let's start with triangle 1. So I've got a triangle, it looks a bit like this. And we want to find it in terms of Z, because we need Z to find W to find Y. It's all linked, okay? So what we're going to do is that I'm actually going to use the cosine rule, because that's my adjacent, it's my hypotenuse. So cosine 30 is equal to x over Z. I can use the exact value for cosine 30, which is root 3 on 2. It's equal to x over Z. Oops. Remember, I want it in terms of Z. So I'm going to make it times by Z on both sides. So Z root 3 on 2 is equal to x. And then, so I'm going to have Z is equal to 2x over root 3. So from there, now I'm going to actually use this value in my second triangle. Oops. So my second triangle now, so I've got this right angle, this is 60. I now know my Z is 2x on root 3. So I'm going to have my opposite, and I need to find my W here. So again, because we found Z, we can find W, which can help us find Y. So let's do it. So I'm going to use my sine 60 is equal to my opposite, which is 2x over root 3. There we go. And that's going to be divided by W. So sine 60 I can make into an exact value. The exact value for that one's root 3 on 2 is equal to 2x on root 3. And remember, when we're dividing, imagine this is like a 1. They'll just flip it. So it becomes 1 over W and multiply it. So the W is actually going to end up on the bottom. So I'm just going to put it there for now. All right. So now what I'm going to do, now I want to rearrange in terms of W, right? So what I'm going to do is I'm just basically going to flip it and do a bit of switching around. So I'm going to make it 2 root 3 is equal to W root 3 on 2x. So from there, I'm going to go to timesing by 2x on both sides. So I'm going to 4x on root 3 is equal to W root 3. I'm going to divide by root 3 on both sides. There we go. So from there, that's going to cancel out. So remember, again, like dividing, that's just going to end up on the bottom again. So that's just going to be 4x divided by root 3. So it's like 4x divided by root 3 times by root 3, which just gives us 4 over 3, which is W. All right, almost there. Final stretch. Let's go. So we've got our final triangle now. So our final triangle looks a bit like this. Oops, a bit wonky though. This is Y. This is 45. This is theta. And my W, which I've worked out, is to be 4x over root 3. Sorry, not root 3. It's just regular 3, isn't it? All right. So now we're kind of thinking, it's not necessarily a right angle triangle. There's no guarantee. So in the original picture, you can see there is no right angles anywhere. We can't assume. It may look like one, but unless it's got that on there, you can't assume it is. So that means, okay, I'm going to use either the sine rule or the cosine rule. Because I've got more than one angle, I can actually just use the sine rule, and I can see there's a pair. So this is one pair, so that side, and then I've got another pair over here. So I've got this here. So let's apply it into our sine rule. Okay, so I'm just going to write down the sine rule so I know what I'm doing. So I'm going to go my y divided by sine theta is equal to w, because this is what w was before, over sine 45. The reason why I did that is because it will make it difficult for later on when I'm going to substitute numbers in and stuff like that. So let's keep going. So I've got to go y over sine theta is equal to, so 10, oh, sorry, not 10, that's w, isn't it? My writing, there we go, w. So my w in this case was 4x divided by 3. I'm going to multiply it. I'm going to divide it by my sine 45 value. So using the exact values chart, sine 45 is going to be 1 on root 2. So because it's divided, I'm going to multiply it and flip the fraction. Oops. So sine theta is equal to 4x root 2 divided by 3. And I'm just going to times by sine theta on both sides. So y is equal to 4x root 2 sine theta divided by 3. And let's check whether or not that's the same. So let's have a look. Look at our lovely work. So 4 root 2 x sine theta divided by 3. We've got the exact same thing here, just that these are flipped around. But they're all multiplied, so it doesn't matter anyway. And that's our final answer. So let's highlight it now in a lovely color. Easy peasy. I know that was a lot to take in, but I think you can manage. Just go through it very slowly. I'm sure your textbook or some other questions that you can find, just do a bit more practice and it will be a lot easier for you. So step it through very slowly. If you need to, go back through the video, kind of see where I got numbers from if you're a bit confused. And yeah, hopefully that helped you a lot. So thanks for watching, and I'll see you in the next video. Bye.